So I hope you are doing well there. Now today I bring one more algorithm of artificial intelligence. In the last class you have seen that we have discussed about A star algorithm, and today one efficient algorithm from A star algorithm actually, that is AO star algorithm. Okay, so guys, if you have not already gone through the previous lecture, I am giving the link below, and don't forget to subscribe this channel if you have not already. Okay, then let's start today's class. AO star algorithm. Okay, so just in the last class you have gone through A star algorithm, and you have seen that A star algorithm is a modified version of best first search algorithm. But what happened? As you know that when we criticize some algorithm, this means that we try to improve it, and in that way we bring an improved version that is known as AO star. Why AO star is an improved version? Because here we focused on not only the AND graph, we focus on AND OR graph. What I have said? AND OR graph. You may note it down. So now questions comes to our mind that what is AND OR graph? Let me give you an example that will be more clearly illustrate this fact or illustrate the use of AND OR graph. Okay, sorry. So as for example, suppose you want to have an iPhone with you. You know iPhone. Okay, that is costly in the sense that if you are a student, then obviously it will be costly for you. So you have two options. First option is that what? Easiest one I have said like that. Suppose you go to somewhere, some shop, and you just steal it, and you get the iPhone to your hand, okay, without any cost. That is the simplest one. And another thing is that you try to work hard, and in that way you suppose crack some interview for job, you get a job, you earn some money, and in that way you can buy an iPhone. Okay, this seems to be a costly, means a lengthier approach, but that will meet your satisfaction. But the first case, when you have stealed it, then whatever happen, if you haven't caught, then of course you know the punishment, okay, penalty for it. Okay, so although that is the smallest one or shortest one to have that iPhone with you, that will cost a little bit what? Higher. So what I have given the example, I can draw it with the help of AND OR graph. Suppose have an iPhone. Okay, now two approaches you have seen. Either you steal it, or what you will do, you work hard, earn money, and then purchase it. Okay, so in this case this is one approach, and this together forms another approach. So we have seen that there is AND in between them, and this is OR. Means what happened? Either you can select this way, or you need to select both of them together. So this implies an AND OR graph. Is this clear to you? Now, how it is related to our searching problem, let me give you an example again. Suppose A node is there, the start node, we have B, we have C, we have D. Okay, So about the heuristic functions that f, z, h we have discussed in the last class. So it's my suggestion, go through it, then it will help you to understand about f, z, h. Okay, now you know that every node has some heuristic value. Heuristic value means to reach the goal node, some value will be calculated and assigned to it. Now say for B we have 5, that value, that adds this value, okay. Then 3 have say 3 and D have say 6. Got it? So at the initial set, this values you got it, this is this value or h value means it will be the cost to reach the goal node. Now at the initial state, what you have seen? You have seen that C has the least cost involved. So what you will select? You will select C because it seems to be the lesser cost involved than B and D. Okay. But when you select C, you will realize that suppose this is forming an N graph with C. This means what? C alone cannot give you the goal node. For the goal node, you need to utilize this D node also. You need to visit this D node also. And together, what will be the cost? 3 plus 6, that is 9, and 9 is greater than 5. So earlier, although you have selected C by looking at its current this value, but you have realized that so while selecting C, you need to select D also, and together they will give you 9, and 9 is greater than 5. So it will cost more. So in such cases, AO star help with you. How? Because in the next step, you have the options to go back to the earlier stage and pick up that node which will give you a less cost involved path. So means again we come here, we come back to A and we pick this B and generate its successors. You know, so one important thing is involved in AO star algorithm is that we move upward for the backtracking. Okay, we move upward to select one node that is that has a less as value. Like suppose for this example, I am generating B's successor as E, F, Z, H, like that. Okay, so you go back to A and select B and then generate its successor, say E, F. Again, you will calculate S values for E, F like that, S value for Z and H like that, and then you will select that successor which has the less cost. And again in the meantime, if you realize that selecting that node will again involve an N arc and that will increase the cost, you will again move upward and select that successor which will involve less cost. That process will repeating until all successors will be evaluated or will reach the goal node. Okay, and one important term is involved in this algorithm, that is futility. So what is futility? Futility means suppose you got a node, say E, from which no more successors can be generated. Okay, that node will be termed as futility. Clear? And also leaves are those nodes, okay, those nodes means those terminal nodes for which the h this value is 0, means you reach that particular goal. Okay, so this is our example for AO star algorithm. So two important things you need to note down for AO star algorithm is that we try to evaluate the successors and we will select that successor by means what? You have, by considering its edge value, and that edge value also will be compared with its other successors, and will mark that path as the best path, which together will give you the less cost involved. And for that we need to move upward also. Okay, clear? So if it is clear, then we can go to the formal algorithm. This is algorithm. Okay, so this is our algorithm AO star. First step, say the initial node is init. We have given the name for the first node as init. Okay, and compute the this init value, means that cost which will be required to reach the goal node. Okay, so first step clear. Then second step, until init is labeled as solve, or age that init becomes greater than futility, then so these sub processes will be continued until we reach the goal node, means we solve it. Or suppose age that init value we got a suppose something like 78 or so, whatever the value, that is greater than the futility. Futility means what? From which we don't need to, means we do not want to generate the successor because its value is too high. Okay, suppose if I want to give you a real example, to reach city C from our current city A, we have several nodes, several paths. Paths will be like that, but we need to select that path which has the shortest path. Okay, but for that we need to go through several other cities, say. But do we need to select that city which will involve the longest route? No, we don't need to select that city through which it will involve the longest path. Okay, we'll select that one which is the lowest one, and also the longest in the sense that is suppose other paths values are 30 kilometers, say 35 kilometer and 40 kilometer, but that path is say 400 kilometer. That is too high than compared to 30, 35, 40, isn't it? So that value you can consider as our futility value. We don't want to reach that value. Okay, that is our futility. The same thing here, means if age dash in is greater than futility, we will just leave it. So clear to you? Okay. Now, so sub processes are: first, trace the mark arcs from init, pick an unbounded node, means that node you will consider which is not yet what? Solve, or which is not yet its successor being generated. Now you pick this node and generate the successors. Okay, if no successors is there, then obviously what we will assign? We'll assign futility to it. And if we can generate the successor, means successors can be generated from it, then for every successor we'll add that successor to the graph. If it is a terminal node, means if that successor is a terminal node, we'll mark it as a solve and assign age dash successor as what? 0. Okay, because it is terminal node. Just few minutes before I have discussed for that example. If it is terminal node, then we'll assign age dash value as 0 and mark it as solve. Okay, then if it is not a terminal node, what we'll do? We'll estimate its age dash value. So these three processes under the sub process 2 will be continued. Clear to you? So this step 2 is, I think, clear to you. Sorry. Up propagation. Now this thing throughout this up to this process, what we are trying to do? We are trying to evaluate every node and its successors, and then try to find out the best solvable node. Okay. Then what we have seen that from that graph. Just let me draw this graph again. So A, B, C, D, E, F, Z, like that. Okay, so these things are now generated. Now next process is what? We'll move forward to consider that, yeah, this one is the best path or this one is the best path. These things we need to consider. That's what the AO star algorithm is aiming for. And these things are considered under steps 3 and its sub processes? Well, let's see. So step 3 I have termed it as up propagation because we are moving up, we are propagating up. Okay, we are propagating like to this level, then say we try to select say this one or this one, like that. Now say S be the set of nodes that have been marked as solved. Initialize S to node. We pick up a node S and node from S, and then we initialize S to node. Now repeat until S becomes empty, means we are continuing these processes until all the nodes of the S being covered. Select a node from S. We select any node from S and say mark it as current. Okay, our current node is what? Current. We term it as a current, and we remove it from S. So remove it from S. Then compute H dash for each of the arcs emerging from current and assign minimum H dash to S. So means what? Suppose we go back to this level and we try to evaluate all this part, and whatever the found, suppose this part is found best, means less cost involved, then we'll initialize this value, this arc to our current arc. Okay, got it. Then now mark the minimum path as the best out of current. If I have found that from D is the minimum path, then we'll mark it as the best path out of what? B, because it has been involved with minimum cost. Clear? Then mark current solve if all of the nodes connected to it through the new arc have been marked solve. Obviously, if all the nodes have been marked solve, then we will mark it as solve. Means our process with this particular node, current node, is complete. Then if current has been marked solve or its H dash has been changed, then the new status must be propagated upwards to the graph. Hence, all the ancestors of current are added to S. Obviously, suppose if we found that this part is the best part, this part has the minimum cost, what happens? We have added this part to our current arc. Suppose above this level also we have some particular nodes, and up to that this is the arc we are propagating through, and then out of these two we have added this arc to our current arc, and we have suppose found that this value, H dash value, is also changed, then we will reflect that H dash value, and then this process will be continued. Okay, so you have got what exactly we try to do through this step 3. So again I am repeating the same thing again from step 1. So step 1 begins with initialization of the first node, and step 2, what we try to do, we try to find it out the best means part coming out of the init, and for that we try to generate the successors. And in the step 3 we are moving means propagating upwards by considering the current path values and current nodes in a state S, and from S each of the nodes will be picked up and analyzed, and then we will select only that path which will be involved with less or minimum value, and that will be termed as the best path out of it. Got it? So that is the whole AO star algorithm. I hope each of these steps are clear to you. So what you have found, whether A star is better or AO star is better. So let me tell you that AO star is the optimal algorithm. Optimal algorithm is that means what? If some nodes is or whatever the node we are searching for is there, it is obviously going to find it out in a minimum path or minimum cost. Okay, but its complexity is higher than the other algorithm. This is the disadvantage of AO star algorithm. Okay guys, so if any confusions left at any of these steps, then do let me know and throw a comment, then I will go through it. And also try to frame one more example through graph based or nodes based searching, then show it to me, throw a comment, and I will go through it. So guys, I hope sorry, you have enjoyed this lecture, and if you really enjoyed this lecture, then don't forget to press that like button. So we'll meet in the next lecture. Till then, take care. Bye bye.